Hello GED students, these videos are on lesson 49, which looks as independent and dependent probabilities. I used the same worksheet that I did lesson 47, simple probabilities, which is number 1 through 6 on the worksheet are simple probabilities. They go with lesson 47, but the rest of them are go with lesson 49. Okay, so dependent and independent probabilities, and you'll hear this also, these two words in science classes, independent variables and dependent variables. But here in math, when they're talking about independent probability, that's where you're drawing two things and where one result does not affect the second result. It'll be like if you have a bag of marbles and you pull out a red one, but then you put the red one back in and then put your hand out and then draw a second one. Since you put the marble back in, you're going to have the same probability. It's not going to affect the results of the second drawing. But here, like a raffle, if you have 50 tickets and you draw a raffle ticket, one person out, and then you draw a second person without putting the original ticket back, well, now there's less tickets. So therefore the second result is going to be affected by the first result. So the second result depends on what happened in the first result. So that's called dependent probability. So I'm going to do number 7, excuse me, and number 8, okay, from the worksheet. So number 7, I already started to save some time here. But number 7, I already have it written there, it's independent. Because it says here there's a jar of jelly beans with the following flavors: 12 grape, 17 blueberry, 5 pineapple, 13 coconut. So what is the probability expressed as a percent if selecting either a grape or a blueberry on the first drawing, but then we're going to replace them. We're going to put that one back and then to see if I get a coconut or a pineapple. So what's the probability of getting the grape and the blueberry on the first drawing, putting it in, and then drawing the coconut or pineapple on the second drawing? So since I'm replacing the one that I pull out the first time, it's not going to change the probability. It's not going to affect the second drawing. So therefore each drawing is independent from each other. The first one is not going to change the second since I replaced it. But how do I figure out that probability? Okay, well, it's just like in 47. You first want to set up the simple probability for the first one. It says here the first drawing, a grape or a blueberry. So what's the probability as a fraction? Well, I have a total. If I add all these up, I got 12 plus 17 plus 5 plus 13. I got a total of 47. I got a total of 47 jelly beans. So that would be my bottom number, the total amount. So here, if I want to pull a grape or a blueberry, what are my chances? Well, it'll be 20, that's 17, that'll be 29 out of 47 possibilities. So my chances are 29 out of 47. Okay? Then, I put that jelly bean out, so I pull one out, but then I put it back in, and this time, the second time, this is the first drawing, the second time I'm going to try to see if I pull a pineapple or a coconut. Yeah, the second drawing there's a pineapple or a coconut. So this would be the second drawing. So therefore, since I replace the blueberry or the grape or whatever one I pulled, there's still 47 in the box or in the jar. But this time I want to see if I pull a pineapple or coconut, so the chances here's 13 and 5, that would be 18. So the second drawing, my chances are 18 out of 47. So I need to combine those. Okay, I'm looking for the probability of drawing a grape or a blueberry on the first one, and then putting it back in, and then a pineapple or a coconut on the second one. So this is my probability on the first drawing, and this is my probability on the second drawing. So therefore, since I need to combine them, you want to multiply these fractions. Okay, and in the fundamentals, they should have showed you to multiply fractions. You just multiply them going across. So I already cheated a little bit. I already worked this out. So this is where a calculator comes in handy. You would just do it on the calculator at this point. Let me find my paper. Number 8. Oh shoot. I might have to do it on the calculator. Here it is. Okay, so you go, I'm sorry, number 7 here. You go 29 minus, or times 18. 29 times 18, that'll be 522. And then I go 47 times 47, that'll be 2,209. So the probability of pulling a grape and a blueberry on the first one and then putting it back in, a pineapple or a coconut, is 522 out of 2,209. Well, I want to divide that down. Okay, I want to say it as a decimal. So what are the probability? So here, I'll do it on the calculator. I go 522 divided by 2209 equals, so it comes out to 0.236. So I'm going to round it to the 100 to 234. So 0.24 is the probability. So 1 out of 4 times in doing it, pretty close to 25%. If I want to make it a percent, I move the decimal point over. So it comes out to about 24% of the time, drawing once and getting a grape and a blueberry, then pulling the second time and hoping for a pineapple or a coconut. 25, almost 1/4 of the time that will happen. Okay? So that would be an example of independent. Now number 8 would be dependent. Okay, so I'm not too organized on this one. Let me find the paper. Here it is, number 8. This one is going to be, well, let's read it here. There are 29 students available to represent the upperclassmen at a fair. 13 are juniors and 16 are seniors. What's the probability as a percent that senior and junior will be chosen? Okay, well, there's a total of 29 students total, and the chances of a senior and a junior. Now, once you choose one, they're out. They can't be chosen again. They're not going to be replaced. Once they're chosen, they can't be put back in. So the total is going to change on the second choice. So therefore, this is going to be dependent. I have over here D for dependent. Because the results of the second choice is going to be affected because one of the students is going to be missing. For example, the first choice, let's say all their names are in the jar, and I pull one of them out, and let's say what are the chances of one of them being a junior? Well, there's 29 total, and there's 13 juniors, so there's a 13 out of 29 chance that the name is going to be a junior. And then the second one, what are the chances of being a senior? Okay, but the second time it's going to be only 28 names in the jar. One of them is missing. I'm not going to put it back in. So you can see here the second choice is going to be affected because one of the names is missing. And again, I don't know which one got pulled, a junior or senior, so this is going to be, I'm seeing the chances of having the senior. Okay? So, and people goes, well, how about putting the 16 over here and then the 13? Well, it's going to, since we're multiplying, it doesn't matter which one you do first. Okay, it's going to be if I do 16 over 29 and 13 over 28. I'm still multiplying the 13 and the 16. I'm still multiplying the 29 and the 28. Okay, so I want to see what are the chances having one of the students a junior and one as a senior if I choose them randomly. I mean, I could end up with 2 juniors, I can end up with 2 seniors, but I want to see the chances of one being a junior, one being a senior. Okay, so here again, you just multiply now. You got to combine these two chances. So 16 times 13 came out to 208. And then over 29 times 28 came out to 812. So those are pretty big numbers. It's a lot easier to look at these as a decimal or a percentage. So it's 208 out of 812 possibilities. So you divide it on the calculator. You go 208 divided by 1812. And I ended up with 0.256. Well, this 6 can round. I just need to the 100th place. So this 6 will make it 0.226. Okay, so that's the decimal. And then to make it into a percentage, you multiply it by 100, or you just move the decimal point 2 places, and it comes out to, I'm running out of room here, move it over, 26% chance. Okay, so the answer would be 26% chance of having one senior and one junior. And then the other 74% would be different. It could be 2 juniors or it could be 2 seniors. Okay, so that would be a dependent example of the probability. Okay, I'm going to stop this video, and the next video I'll do 2 more examples of an independent and dependent.